Good morning, everybody. Welcome to the Purdue University webinar series presented in partnership with Accenture. In our webinar series, we've presented how AI is used in such good ways as fighting human trafficking, maximizing human potential, and supporting the healthcare industry. Today on Earth Day, we're happy to present how AI is being used to protect our planet. I am Matt Lawrence, the Managing Director for the Krenicki Center for Business Analytics and Machine Learning at Purdue University.
Sorry, Matt. One second.
Yeah, you got it, Megan. Of course, it's asleep.
Why it's not moving. There we go.
All right. The Krenicki Center, the mission of the Krenicki Center is we collaborate with faculty, students, corporate partners, and we enhance the research and dissemination of state-of-the-art information, technologies, and analytical techniques to utilize the vast amounts of data available today to deliver actionable insights into business decision-making. The mission is to facilitate student learning opportunities, lead industry collaborations through research and data science and AI-focused, solution-focused projects, and provide leadership via conferences, roundtables, and webinars. Purdue identified sustainability and AI as two of the four thrusts during its Giant Leaps campaign as part of the 150th anniversary 2 years ago. Purdue is helping to build a sustainable planet through dedicated centers that impact global sustainability, such as the Center for Global Food Security, Center of the Environment, Purdue Climate Change Research Center, and Purdue has award-winning research and academic programs. We have had 3 of the World Food Prize laureates since 2007 that we're very proud of. We have programs in agriculture, forestry, energy, climate change that are combined with data science, engineering, math, and computer science to enhance the studies and the research in those programs. The Krenicki Center is the center of that intersection. We provide, as I said, the solutions, and we engage with our corporate partners to introduce those capabilities throughout the university and the various programs and our faculty and our students to solve your complex data challenges. I welcome everybody to the webinar today, and just a little bit of logistics. We will ask you to use the Q&A function on your Zoom screen. And we will have a Q&A session towards the end of the session here, and that will be moderated by John Machette. John Machette is a Senior Managing Director at Accenture of Applied Intelligence, which is the practice of specializing in artificial intelligence, analytics, and automation. He also sits on the board of the Krenicki Center and is a proud Purdue graduate. Without further ado, I welcome you to the webinar and introduce you to John Machette.
Hi, folks. Good morning, everyone. I presume it's morning for everyone, but I would echo the sentiment that Happy Earth Day. It is, of course, not a coincidence that we're having this discussion today. So, as Matt said, we started this webinar series in the fall, and we've had some really excellent topics. The first one we did was AI for Good, and then we had a good session with the dean, in fact, dealing with the future of workforce and all the digital implications. But today we're going to focus on the topic of sustainability. And so to do that, well, first off, there's no doubt in this post-COVID world, it's super important to get this right. I can tell you, in all the clients that I speak to, it's now a C-level conversation. I can tell you that sustainability is one of Accenture's primary objectives. We have a scorecard that we measure ourselves on globally, and sustainability is one of them. So we're going to talk a little bit about what's the state of the art, actually what's happening. And to do that, we have 2 amazing guests that I'll introduce in just a second. But they're going to share some stories about some things that are happening that are really cutting edge. I think if you had gone back, pick 10 years and said, hey, what can AI and analytics do to assist with the sustainability? I'm not sure there would have been an easy answer to that question just even 10 years ago. But today, it's what's happening is really exciting. And so we'll get to hear a couple stories. So 2 speakers in the panel today. So the first is we have Samta Kapoor. I think you can see her photo. And Samta is a managing director in Accenture. She has over 10 years of experience driving really transformational change programs, dealing primarily with AI and analytics. So Samta has a broad range of responsibilities. A lot of the work she actually does is in financial services, but she gets to play across the entire patch of the West Coast for us as a leader in our AI business. So Samta's educational background, she has an MBA from Kellogg, so it's Big Ten, not Purdue, but close by, and that's cool. And she also is an engineer from Duke University. So there's Samta, and we'll hear her story. And next we have a very excellent leader, Anurag Harsh. And so Anurag, this is going to be hard to believe, but he was voted LinkedIn's #1 voice in technology, so that's impressive. But he is the chief data officer of a $30 billion construction materials company called Lafarge Holcim. And if you don't know a lot about Lafarge Holcim, you'll learn more in just a little bit, but they're a very interesting company. And so, Anurag's role, again, if you're familiar with like the CDO function, there's a lot of ways to make a difference in an organization, but certainly, bringing the very best of AI and, industry XO to the forefront to make transformative change is what Anurag is all about. If you Google Anurag, it'll go on for pages, but he's authored seven books, has over 500 articles, and just is extremely prolific. So Anurag comes from MIT, has an MBA and an MS, and I think lives in Boston. So welcome Anurag and Samta. Okay, so let's just kick into it. We're going to start with Anurag. And I guess is the photo behind you, let's just start there. Is this a plant from Lafarge Holcim? Anurag, can you tell us about the picture behind you and a little bit about Lafarge Holcim, please?
Sure. Well, thank you, the Krenicki Center. Thank you, Accenture, for the opportunity to come and present and talk about our sustainability efforts with AI. Yes, John, the picture behind is our cement plant in Kujawi in Poland. And it's an example of what a typical cement plant looks like. Very briefly, Lafarge Holcim is, as you stated, a building materials company. We're actually the world's largest building materials company. We are a global leader in innovative and sustainable building solutions, shaping a world that works for all people and for the planet. We're roughly 25 billion in net revenue. Our global headquarters are just outside of Zurich in Switzerland, with a presence in over 75 countries, including the largest building materials company here in the United States. We have over 20,000 operating sites, and we're active in 4 business segments. We manufacture cement, aggregates, which are these little stones you guys see, gravel and things like that, concrete, and building solutions and products. A lot of people don't realize is that cement and concrete, 2 of our products, are the most used substance on the planet after water. We've been involved in some of the largest and most renowned infrastructure projects globally, including the World Trade Center in New York, the Tappan Zee Bridge in New Jersey, et cetera. We've leading positions in most cases, the largest player in the market in all of the regions in the world. And it's a pretty balanced portfolio between developing and mature markets. What we're trying to do is solve the challenges that people face around the world, whether they're building individual homes or major infrastructure projects. And so, a lot of the demand for our materials and our solutions is really driven by global population growth, urbanization, improving living standards, sustainable construction. And so our goal really is to move the 2 billion or so people on Earth into the fabric of society with housing, schools, bridges, banks, roads, daily living infrastructure over the next 2 decades, where 60% of the infrastructure to support them has not been built yet. And so, obviously there's a lot of opportunity for green construction in there. We're about 70,000 people, that work for our company that we're really proud of. And, one of the things I'd like to add here is that although we're going to be talking about analytics and data and AI and machine learning today and how that's helping sustainability and carbon emissions reduction, let's not forget that we're still in the thick of the pandemic, and we have been for the last year or so. And a lot of the work in sustainability and really, keeping the lights on has been because of our frontline workers and our colleagues and and people who have tirelessly been working to keep things moving. For example, our 70,000 people, we built emergency field hospitals, in Wuhan and all the way in Boston. We sanitized public spaces from Ecuador to India and promoted public health in Kenya to the Philippines. And, and I'm sure Accenture and the Krenicki Center have been involved in very similar initiatives. So, before we look ahead and go down the rabbit hole of advanced analytics, let us acknowledge the unprecedented solidarity shown by all of our people to our communities worldwide, and this is all the more exceptional in these very challenging times when we're all concerned for the immediate safety of our families and our loved ones. And to me, to quote Paul Dougherty, one of my really good friends, the CTO of Accenture, it's about human plus AI. AI doesn't happen without the human element. And that's what we're about in Lafarge Holcim.
I wanted to ask, that's a great background into your business, and I think your comments at the end about respect for the frontline workers and really treating each other with grace is important. And I think we're learning a lot about how to do that more effectively as a network of professionals. And I don't think we're that great at it in the beginning. We had to learn. So before we talk about some of your programs and the AI, I know that at Lafarge Holcim, this concept of green manufacturing and sustainability is incredibly important. So before we get into like what you did and kind of what you're up to, just can you talk a little bit about why is it so important to Lafarge Holcim?
Yeah, no, absolutely. Thank you. I mean, look, I'll give you some numbers. The world emits about 33 billion, close to it, metric tons of CO2 into the atmosphere every year. The building materials industry is approximately anywhere between 7 to 9% of this number, on average 8% of this number. So everything that we do, it counts. So even if there's a little bit of a difference that we can make in the emissions from one cement plant or one concrete facility at scale, because we have 20,000 installs around the world, it starts to really add up. And so what we do matters. And we are, as a result of that, reinventing how the world builds to shape a world that is greener, smarter, and that works for all. And so a world that's low carbon, and it's circular in some ways for a net zero future. And I'll talk about that a little bit. And so we're driven by innovation and digitalization. For me personally, is about making more with less, a world that improves quality of life for all. So we're definitely, and so we've pledged, for example, to net zero, which is our ambition, is to lead the industry in reducing carbon emissions, spearheading the transition towards low carbon construction. And we are a leader, I would say, in promoting a circular economy, which is from alternative fuels to concrete recycling. And so, just so you guys understand, where majority of these CO2 emissions come from, there are other industries, textile industry, clothing, manufacturing industry, the oil and gas, but our industry is a big part of this. And if I may take 1 minute of everybody's time here to give you and I'm going to talk a little bit of technical talk to give you an understanding of the cement manufacturing process and why it matters, because it is the most used man-made substance on the planet. It builds economies, it's makes and break governments. It's a major driver of human infrastructure. 1 ton of cement produces 1.25 tons of carbon dioxide. So 1 ton produces $1.25 bucks of CO2. Now, these cement and concrete is produced in these very large, capital-intensive production plants, but are generally located like the one behind me, is generally located near limestone quarries or other raw carbonate mineral sources. And these sources are the principal raw materials used in the manufacturing process. Now, because the production plants are expensive, $500 million, $1 billion per plant, the number of plants is generally limited. And so the CO2 that is emitted as a byproduct of the clinker production, and clinker, by the way, is an intermediate product in the manufacturing process, in which the CaCO3, which is the calcium carbonate, it gets calcinated and it converted into lime, which is CaO, which is the primary component of cement. And so this CO2 is also emitted during the production by fossil fuel combustion. So 1 ton of cement produces 1.25 tons of CO2. And we're talking about 33 billion metric tons of CO2 on an annual basis across pretty much all of the industries. And so, we're talking about sizable numbers here. And so for us, this suddenly becomes really important. So we are actively working on reducing these emissions. We've signed the business ambition for 1.5 degrees Celsius pledge with the science-based intermediate SBTi targets in alignment with a net zero pathway, from shaping the plants of tomorrow with automation and artificial intelligence to accelerating green solutions. So we're looking at things like carbon capture, green products, plants of tomorrow, renewable energy, clinker factor alternative fuels. And so the circular economy that I was talking about a little bit, that benefits the business society environment while simultaneously eliminating waste and decoupling that development from consumption of finite resources. Look, the building and construction sector, my sector, consumes roughly 40 billion tons of the raw materials that are extracted from the planet every year. So against the backdrop of rising population growth and urbanization, the OECD expects this volume to double by 2060. And that's obviously representing a great challenge for society, right? So our vision is to enable a circular built economy that really starts with the preservation of natural resources by substituting these fossil fuels and raw materials with waste or byproducts. And let me tell you a little bit about waste. LafargeHolcim is the second biggest waste reuser globally. In 2020, we reused 46 million tons of waste and increased by 4% our recycling ratio, which essentially measures waste per ton of product sold. And so we transformed some 5 million tons of waste into alternative fuels, and then we recycled the minerals and recovering the energy. So, co-processing alternative fuels is about 11% of all the waste that we recycled, and it includes almost 2 million tons of plastic waste. And as you can imagine, there's a good amount of AI that's involved in all of this. And so, we're doing a lot of like water usage, for example. We're in a lot of developing countries. We are building the size of New York City in sub-Saharan Africa on a monthly basis. That's how much construction is going on. So we have to consider, and water is a big component of the production process. That's one of the reasons why we're close to the river systems. Our total impact on water resources in the communities where we operate, particularly where, there's water scarcity. So we're optimizing and preventing, in some ways, the use of fresh water, as well as reducing the risk of depletion or pollution by measuring our operational water footprint, reducing fresh water withdrawal, assessing the water risks, engaging with stakeholders on sharing this water and providing more water to the communities. All of this, requires AI. And not only water, if you look at air emissions of the manufacturing process, what is the goal here is that all of our sites, we measure these emissions. In 2020, we monitored dust, NOx, which is oxides of nitrogen, especially at atmospheric pollutants, SO2, which is sulfur dioxide emissions from 97% of the product that we produced. And so our overall dust emissions reduced by about 13% year over year, and NOx by about 0.3%. All of this involves AI. And I would say, lastly, that, community is important. We are committed to really making a positive difference for our people communities where we operate, right? And we're a global business. We're operating very locally in each of our 75 markets. We employ local people, and we're implementing sustainable procurement and establishing open relationships with the communities. And these are the core. So 92% of our suppliers, for example, are from the local and from the national market rather than from the global market. So these are some of the things we've been doing in sort of green construction and sustainability.
I have another question. So that was a good overview of really good 360-degree view of your business, and a really good explanation of like the opportunity ahead of you. And in some ways, some of the complexity. You're dealing with so many dimensions in your business, and so that I think is eye-opening for me, and I'm sure for a lot of the folks on the call. So as you know, I mean, Krenicki is about ML and AI and for business use, and I know that you've thought a lot about this, and that's factors heavily into your approach. And so, just to peel the onion a little bit on your org, so tell us a little bit about some of the scope of ML and AI, and I think it would be surprising. I think if you just pull like a random person off the street and say, hey, how does like ML and AI affect concrete, they probably wouldn't know. But obviously it's pervasive. And so if you had to focus just like on some of the advanced techniques you're using to assist with this mission that you described, like what are you up to?
Yeah, I mean, we're working on an enormous number of initiatives, hundreds and hundreds of AI initiatives. Look, I mean, there is low cost production. So obviously there's competition from those guys. Energy costs are high. There's CO2 challenges that I just talked about. The resources are scarce on the planet, water especially, because you can't produce without water. There's talent shortage. And so we got to future-proof our concrete and cement plant operations. It's as yet, the planet hasn't come up with an alternative. For example, my alma mater, MIT, has come up with alternative, green concrete. It's difficult to actually, how are we going to produce it, right? I mean, the cost of production distribution is considerable. And I would, in fact, argue it's crippling. I mean, it's almost impossible to really get that out. And so we got to work with what we have, and we got to make it better. And so we got to really drastically rethink our operating model. And so we started this initiative called the Plants of Tomorrow that essentially is pushing new technological boundaries using artificial intelligence and machine learning. But essentially, there's four most pressing needs, I would say, that we have: using AI and ML to maximize the efficiency and productivity, reduce the waste and emissions, future-proofing the plants and infrastructure, and then we're looking at adapting our asset footprint at constant production capacity. So our focus has been on implementing 6 critical, you can boil the ocean here because there's a lot to do, but we focused on 6 critical solutions in 3 phases, and I call it digital, circular, and interconnected. And really what these 6 solutions are is we focused on analytics-driven predictive maintenance, predictive quality analytics, and there's a couple of examples of that I'm happy to talk about if you'd like in some more detail. Predictive energy optimization and management, end-to-end process optimization via digital twins, which is essentially replicating the entire plant onto a computer, modernization of the plants, autonomous operations, and then integrated and interconnected operations production sites. And, I'll give you an example of some of the things that we're involved in AI, right? We're looking at artificial intelligence to predict new project demand, right? Where is new construction happening? And it's happening everywhere in the world. Overall supply network optimization through the improved association of quarries with the plants. How do we optimize stock and RFID tracing of the raw materials? Is there a way that they could be early warning of the emissions, the leaks, and the errors via automated drone monitoring? Obviously, I talked about quality prediction, and we can talk some more about that. Is there a way to improve the replenishment of our product through connected machinery and autonomous robots? We are looking at augmented reality for visual inspection of equipment and faster maintenance intervention, exoskeleton technology for increased operator safety, digital twin technology of the production process, essentially creating an end-to-end transparency and supply chain connections. We're looking at energy optimization, alternative fuels. It's a huge area for us. Looking at robotics and cobotics, which is human plus machine, to perform tasks under heavy pressure and high heat. You know, we've got these little drones that go inside our cement kins, which are at 1800 Fahrenheit, and you can imagine no camera is going to survive there. So we have these audio sensors in there, you know, they're sort of capturing all of the audio, converting them into spectrographs, sort of like when you actually load your sound MP3 file and it converts it into a wave, and then you can do all kinds of analysis with it. It's really cool stuff. Then we're looking at, you know, soft sensors, wearable sensors for the closer monitoring of process and safety, or AR to support warehousing activities and loading, or big data analysis of third-party logistics, you know, to optimize, you know, warehousing capacity and cost. So there's lots of different areas we're looking at, but fundamentally what we want to do is improving our planning horizon from an average of 1 week to, let's say, a quarter or 13 weeks through AI-driven predictive maintenance, quality control, energy management, you know, enabling the most optimal utilization of financial and human resources. And what financially really means low cost sourcing, and human resources mean increased productivity. And then mirroring, and that's sort of like the digital part, I would say. Then the circular part would be, how do we mirror the entire production process in real time through a digital and an AI model, sort of a twin of the plant's physical assets, processes, the systems, and then how do we modernize these plants through intelligent robotic automation? Like, how do we use AI to optimize the digital model, implementing the settings needed to achieve the most competitive production costs at the lowest possible environmental impact, maximizing the alternative raw materials and fuel consumption. And finally, I would say interconnected, you know, which is positioning us to streamline our asset and environmental footprint, and with it, alter our current plant operating model. So essentially moving from a decentralized plant operations to more of an integrated, more of an interconnected asset network management, from sourcing to making, and then finally to delivering it to our customers.
And that was really interesting. You mentioned so many initiatives that you're looking at. I think we could probably take any one of them and spend, you know, a whole discussion on those topics. I'm going to move on to SAMHSA, but Anurag, we're going to have a Q&A later. I'm going to tell you the first question I'm going to ask you, and we'll get some from the audience. But I'd like you, what I think would be interesting is if we could just take one of those and just tell a really cool story, something like the folks in the call, they could go to some other people tonight and go, you know, I was on this call, I heard this guy, Anurag, talk about his business, and he said something that was really crazy. Like some of the results you got, the data, the AI, something you didn't expect, something that was, you know, unpredictable, but interesting. So I'll give you some chance to think about that, but I know people would like a really just hard-hitting example. That would be kind of slick. So that's coming. So SAMHSA, I see you there. Making AI everyone's business, I see is your background. So that's a good topic here on Earth Day. So SAMHSA, I know that you have a lot going on. You're going to tell us a little bit about a project that you've been working on. My understanding is the client's name, would they prefer not to use it? So we'll just talk in a little bit more general terms. But you have a really good story, and just tell us a little bit about what you got going on in the West Coast.
Sure, absolutely, John. So today I'm going to talk about wildfires, and it's actually, though we're doing it at a couple of clients, it's applicable across the West for all of our utility clients, actually. And I'm going to assume that we have attendees from across North America, and not everyone has been in a wildfire or experienced it. Thankfully so. So I want to just kind of talk a little bit about how grave the situation can truly get in terms of like wildfires and what really happens and what does it mean to people like us, and also sustainability in turn, right? So just to give everyone an idea, in 2019, the wildfires that happened, they destroyed 4.4 million acres of land. And the Fed had to spend around $5 billion just to be able to respond to those wildfires. And since 1985, of course, we all know how things have been changing with the climatic conditions and the population and all the good stuff, it has been approximately 1,000% increase in the fire suppression costs, just because it's been so massive and it's affected everyone, right? It affects people like you and I. It also affects people with disabilities, with medical equipments. Like if you think about your power going off and your medical equipment is powered by electricity and or gas, like there's no way for you to really get out of that, right? There are actions in place, but wildfires can be very destructive, and they're very disruptive to lives. The smoke from wildfires causes a lot of increase in mortality. So the death rates go really, really high. And we have experienced, I moved to the West Coast 2 years ago and 2.5 years ago. And for the first time, when I experienced the smoke, and I relatively like to call myself as a healthy person, I literally could not breathe. Like the whole day the skies were orange. It felt like it was coming out of an apocalypse. And then it was just really hard to breathe. Kids were not allowed to go out. Schools were shut down. And that was just the minutest of impacts that were there. So what we are doing here with our clients, and which I am very excited and proud about, because we are able to use data, AI, ML for making sure that we're helping them make smarter decisions. And it's not anymore a gut-based or a hypothesis-based decision, right? We're also using a lot of LiDAR data, satellite data, drone data to help them use images as one of the sources to make these decisions better. Now, while wildfires can be caused by a lot of natural reasons, there are also reasons that you all would have seen have put companies in the news, like asset mismanagement, for instance, right? So what it means for our clients is billions and billions of dollars in fines, reputational loss, and a lot of harm to the people that they're serving. So we're enabling them to make these asset-based decisions as well by using all the massive data that has been gathered over all these years.
Okay, that's great. So you said you were using video or images. And so, when you think about, there's different definitions of AI. One of them I've heard that I sort of think is very simple is anytime you're using machine learning, document understanding, or computer vision, it's de facto AI. Those are what humans do. And so I think what you were saying is that you're using computer vision technology to assist with this problem, which, sort of like AI and concrete, I think people, wouldn't have sort of de facto like presumed that such a technology could be used to prevent forest fires. So can you tell us a little bit more about how you're using computer vision to assist with this problem?
Absolutely. So what we're doing, John, basically is that, so everyone knows that satellite images and like running drones over assets can be really, really expensive. So we're trying to change the game a little bit. So what we're saying is that you have to have, you have to do your inspections for your assets. You have to do those inspections manually. You have to send drones and you have to do multiple things around those. So why don't we use some of the drone images that you would have anyway, do analysis on those images, detect the asset in the first place, and then understand what the defects on the assets are. So that's how we're using these images. What we're doing now is a little different, and we're in the proof of concepts phase for this. So it's very, very new. But what we're trying to do is using our iPhones, right? Can we help the field service delivery resources that are on the ground that have to take rounds anyway, instead of flying those expensive drones and doing all the manual checks? Can we capture images using our basic iPhone, do edge computing, identify whatever the relevant assets are on the edge itself, and then connect them to the cloud, run our models on the cloud, identify defects, and then have these results handy so that all the decisions that are made based on data, and all these expenses are under control. So that way more focus can be on fixing the assets and using the money across different categories of assets instead of trying to just do the inspections. So that's how we're trying to change the whole inspection area.
Okay, that is certainly interesting. And something while I got you, I wanted to put you on the spot a little bit because there's so much going on the West Coast, and the wildfires is part of it. I know though that there's some other work that you and your colleagues are doing in the area of ocean protection, which is sort of also another mind-boggling, concept. And so when I got an overview of like what you guys are up to, it really made me think. And so I just, for the folks on the call, in like 30 seconds, can you give us an overview of what you're doing with ocean protection? Like what does that word even mean? That's kind of a big word, right?
Yeah, no, that's a great question, John. So as we all know, in the ocean these days, or any water body basically where you can have human beings around them, there's a lot of plastic and everything that gets thrown into the ocean, right? And there have been multiple initiatives. There's a lot that everyone wants to do with it, but it's really, really hard to control it. So we know that plastic is taking over the oceans, and by 2050, there's going to be more plastic in the water than fishes. So what we are trying to do with that program is basically get pictures and use those images to make decisions as to where the ocean needs the most cleaning, and use that data to attack is not the right word, but to get onto that spot and clearly know in such a vast body of water, where would you have to go to make sure that you're able to get the most out of the deposits that have been put in the ocean.
So how do you do that? I mean, the ocean's a big place, right? And a lot going on. So how does one use data and AI to do this?
Yeah, no, it's a great question, John. So we're collaborating a lot with the governments and the state bodies. And what we're doing is there are like with the flying, like whatever, like the aircrafts or helicopters or whatever we're mapping that area is how we're gathering the images. And we're trying to get it closer from the borders of the ocean, because that's where most of the deposits are. And that's how we're mapping those areas.
Okay, that's great. That's great. Yeah, I've heard you actually have sensors in the water. In some places, it's not just airplanes. So there's various sensors under the water. It extracts the data, I guess, puts it into, I don't mean to get cute with a pun, but like a big data lake, and then you can do a series of analytics, just measuring temperature, pollution, salinity, you name it, like whatever is going on. So it's really kind of a mind-boggling enterprise when you think about it.
Yeah, no, it's been a great initiative.
Okay, I got some more questions for you on this, and also Anurag. I'm going to do just one more person that's on the call. Megan, Niles, are you out there?
I am.
Hi, folks.
Hi, John.
Megan is a leader in Accenture who helps coordinate, a proud Purdue alum herself, and has been assisting with this. Her like day job, I suppose, is to work with Accenture marketing as it relates to AI. And then we all have sort of our labor of love projects, and Megan has been an instrumental leader in helping with this Purdue series. So we're going to do some Q&A, and so I think we probably have a number of things teed up. I have a number of questions on what we've heard for both leaders, and I'll seed it with a couple. First off, I got three kind of in my head, but I want to come back to Anurag. I promised Anurag to circle back, and like one kind of cool story. People at the dinner table tonight, and they said, "Did you know this?" And then like what are they going to tell their friends?
Yeah, I don't know if this is a dinner table conversation that's worth talking about, remembering, but I can tell you, it's the first time that a lot of the work that I've personally been doing, I can have a conversation with my kids, they're young, and tell them that a lot of the work that we're doing, your father does, has an impact on the planet, and that's kind of what it's about. So I'll give you an example. I mean, it's a little technical, but it at scale, this has made a difference. It's the SEMQ initiative. Actually, we did this with Accenture. It's a SEMQ initiative. It's called Cement Quality Prediction. What is that? And we did this in 5 plants in Europe. Now, so that our homes, our schools, our bridges, our roads, our tunnels don't all crumble and collapse, the strength of the concrete, of the cement that builds them, becomes kind of a big deal. And the product must attain strict standards as far as strength development is concerned. And so predictive quality models enable the forecasting of this quality accurately in real time at any point during the production process. And that reduces the typical overspending of up to 10% in efforts to meet quality targets. Now, it used to be impossible to estimate the strength of the product with any certainty until its first day, because that's when you're starting out. And then there's this benchmark we have on day 28 when we do these physical tests. And therefore, because you could only do it on the first day or the 28th day, what the factories would do is that they would essentially additionally add some safety margins on the product, either fineness, which is demanding for more grinding energy and cost, or what they would do is increase the clinker factor, we call it, meaning that they compensated for this by using costly, higher quality, clinker and additives to ensure a high performing product and reducing the amount of inert materials, which are fillers, such as limestone, using strength enhancers in the product or a combination. And so the plants would mill the product more extensively, as the finesse of the grind was also another factor in determining the final strength. So why am I talking about this? Well, these approaches are very expensive, and it really offered no way of accounting for the multitude of other production process variables that would affect the quality. And they were also very carbon unfriendly, right? And so in contrast, the predictive quality model and the tool that we built essentially uses machine learning algorithms to correlate the quality of each production batch with the relevant production parameters while minimizing the clinker factor. And there are several variables that are involved in the final cement quality that are intertwined and making it very difficult to determine the impact of each factor at every step. And so the AI basically lets the system learn over time to associate all of these process parameters, temperature, humidity, tensile strength, and the raw material characteristics, with the quality outcome. And so through the predictive quality analytics, through this project, the plants, we build a model that essentially provides the necessary quality of the final product based on guided input at every step of the production process. And so in a nutshell, what we did was we built this tool. And that's a live industrial grade, living, breathing AI tool that provides near real-time prediction in short and long-term time horizons. And we call it SEMQ, and essentially the manufacturing team at the plant is able to make adjustments to their production parameters and to manage their quality proactively. It uses, for the data scientists out there, just a little, geek plug, uses 6 competing algorithms. It's trained on 3 years of data. It handles some 18 different types of product, cement types, and it handles some 143 odd files every single day. The prediction trends and the quality metrics are displayed through a browser screen on our internal system through a VPN, or we can also do it, two-factor authentication on a web URL. Why is this important? First, we deployed this across our plants in Germany, Czech Republic, Spain, Croatia, and Greece. And what we observed is interesting. And here's the numbers. What we observed, just with 5 plants, is a reduction in the clinker factor in the cement. And therefore, remember what I said about 1 ton of cement is 1.25 tons of CO2. So there was a reduction in the overall CO2 emissions of, here's the magic number, up to 13,000 tons per plant. That's a huge number. And then what we found was an overall reduction in the electrical energy for the cement grinding, because you're not grinding as much. So there's an overall reduction in electrical energy. What does that mean? Lower emissions. And there is a reduced variability of the product, because now you can measure it. So the variability is not as volatile, which means the energy consumption was also limited, right? And so what we did was we built a roadmap to realize that, we did this in 5 plants. What if we do it across 200? So what we realized is the CO2 emissions reduction and saving beyond the initial 5 countries, rolling it out across all of our plants globally. And so it was quite an amazing discovery for us. We did this project in 41 days, and we found this very, very, very interesting and very valuable to a lot of our efforts. We've done a couple of other projects with with Accenture on demand forecasting, which also has a very big carbon footprint reduction. And if you're interested, I could tell you about it. But this is the cement quality. I thought was quite interesting.
No, that's interesting. And the speed at which you got results, I think, is telling. That's one of the things I think is so exciting about being in our profession today, is that with just some good data and some good models, you can get a tremendous amount of benefit. And the kind of projects that, if you just go back, even 5 years, it would have taken, a year and a half just to sort of get everything assembled. So that is interesting. That is awesome. I wanted to go back quickly to Samta. I got a question for you, Samta. So I'm thinking about your utilities example, and the more I think about that, it seems like a really difficult problem. You're dealing with the health and safety of a very large citizen population. It extends over, California. If you've seen a map, it's a big place, right? So it's a large geographic area. There's an immense amount of equipment and equipment types that are add to the complexity. You have to balance cost and effectiveness. I'm sure there's political considerations associated with this. And then at the same time, you're dealing with the application of a whole new branch of science, really, to address this problem. So you put all these ingredients into the stew, and it looks difficult. So I'm just wondering, but that's I'm a novice sort of listening to your story. I was wondering, though, if I ask you, like, what, as you've executed this program, if you've laid out your roadmap, if you got results coming in, like, what is it that was actually hard to you? And then what advice would you give to the people on this call about what you did to resolve those problems? And maybe it's not any of the above that I mentioned. Maybe there was some real practical matter that you had to crack first. So I'm just curious, like, what was hard and what did you do about it?
Yeah, John, that's a great question. And to this too, I'm also going to add trying to bring in third-party data, because weather plays a very important role when you're trying to, determine the asset health, for example, or trying to determine the consequences of failure. So yeah, you rightly laid out this too. And I'm not going to say that it was an easy problem to solve, but I think a few things that stood out and that were exceptionally hard or challenging were two things. One was the data. So the biggest challenge was our clients have data, the same data for the same assets in different source systems. And not every time do you hear the same story about that data, right? Especially when you're thinking about transmission assets, distribution assets, and trying to make decisions on those. You need to have, because AIML is, as we all know, AIML is as good as the data that goes into it, right? So garbage in is garbage out. So the biggest challenge and the biggest hurdle for us was to first get that basic foundation in order. And I think what was exciting there was that we were able to use AIML to just get the foundation in place. So to avoid duplication, we were able to use our algorithms to make sure that we were able to do it. And what that meant for human beings like you and I, and also our clients, was that the process was much faster. Like, they didn't have to do it piecemeal in over 10 years, but we were able to do it very efficiently and very quickly. So that was the first thing that was really hard to tackle and that we had to tackle to make any progress in the project. The second thing, being very transparent, was being able to bring a team of diverse ways of working, right? Not only diverse skill sets, but also different kind of thinking in a room to be able to brainstorm this huge, massive stew that we had to build. And in this case, we had to be very, very precise, like a proper Michelin star chef, and not really just throw ingredients in and figure it out like I do at home, was the other challenge that we had faced at the beginning of the project. But I think once we got the these two things in order. It was, I'm not going to say it was easy because it was still a new technology that we were testing out. We were trying to bring in third-party data, include it with first-party data, and do all these integrations and get it all right. But I think once these two things were taken care of, it was relatively easier moving forward.
Okay, thank you. That's great. Okay, I'm going to ask maybe each of you the same question. I'll start with Anurag, one that's come in. So again, we've said, look, if you had gone back a few years, you wouldn't have expected that you would be using computer vision for wildfire reduction. You wouldn't probably have expected you would be using, AI for cement quality. But here we are, and it's a reality. So I'm wondering, Anurag, in your position, you're overlooking not only a global business, but you have a lot of connections and experience just in the industry. And so when you look out in the next 5 years, like what is it that you're personally interested in for yourself or for Lafarge Holcim? Like what do you see coming that is the next wave that is really interesting for you?
Oh, thank you. That's a fantastic question. I mean, look, somebody actually on the chat mentioned that they were reading the Gates Foundation report. And one of the things, if you read those reports, is the world is getting less and less poor. That's just a fact. And, polio, for example, is getting eradicated from Earth. Malaria, et cetera, is, everything is on the DL. And so on the down low. And so what is that happening? What is the effect of that? Well, a lot of people are coming into the fray of society. They're coming out of poverty and they need infrastructure. They're coming into urban settings in cities. And I feel that most of the resources in the world are ultimately channeled into cities. The municipal governments have a unique opportunity to mitigate, I think, climate change. So city governments, they regulate and sometimes they operate, transportation, buildings, economic activity. I mean, here in New York City, which is where I am, that's the case. They handle things like energy, water, waste, crime, health, noise. And so data and machine learning have become very common for improving efficiency in these kinds of areas and giving rise to the notion of what, I think is called smart city. Now, smart city encompasses a wide range of technologies, but I'm more interested in those that are relevant to greenhouse gas emissions. So, important aspects of city life, things like, for example, hard sensing, like fixed location dedicated sensors and traffic cameras, or soft sensing sensors and mobile devices, things like that. How do we collect data from smart cities and city applications? How do we adapt to precisely meet the requirements of the communities that are growing inside the cities? New York City, for example, is 5 terabytes of data just from traffic cameras every single day. I can tell you that we can forecast on a block by block basis. We're not doing that right now. If an accident is about to happen, I mean, the technology exists. It's just that we're not doing it. And so I think that's what is interesting to me, where we are collecting copious amount of data. How do we set up an infrastructure within our government system at a local level that is able to process this volume of data and start to cluster it, maybe anonymize it and start to make some real predictive decisions around it that makes everybody's life better. And that, I think, that's something that personally is of interest to me.
Yeah, it's probably is doable in a 5-year kind of horizon. It sounds difficult, but I bet we can do it. Hey, Samta, I'm going to ask you the same question. So you are now, you've moved, you've had a lot of sort of experiences as you got to where you are, but you're currently sitting in Silicon Valley, a center of innovation, not the only one in the world, but certainly one of them. And you get to see just a lot of transformational change. And so when you think about Earth Day and sustainability and kind of the experiences you've had, what do you see in 5 years that is really exciting and something we ought to be thinking about?
Yeah, so John, I actually think in 5 years, hopefully, fingers crossed, and I know this might be ambitious, but we can truly solve for world hunger. I feel very passionately about it. And before COVID hit, I had started with a team actually within Accenture working on a pet project where we, everyone wanted to really truly see how we could make it work. And we were thinking about how much food, perishables and non-perishables, is truly wasted is not the right word, but after big functions, like all the get-togethers, even things that we do in office, how that food is there that could actually help people across the globe. And what we were thinking of is we could partner with United Airlines, American Airlines, look at, the food that's there. How do we build like a database with the data that we can gather from different companies, Accenture included, to know where the functions are happening, what is going on, the workshops, food coming in, and then collaborate with the airlines to kind of get their schedules. And then it would be a big supply chain problem to solve. But we were getting started. And then of course, COVID hit and a little change of plans, but I'm hoping in the next 5 years, we would truly be able to do that. And then that proverb can go out of the window. No one can say, do you really think you can solve for world hunger? Because there we would be doing it truly.
That would be an amazing outcome. Hey guys, we just have a couple minutes left, so I want to end this discussion first off by thanking both of you. It's been really interesting to hear sort of the diversity of answers and perspectives, and inspiring, really. But I wanted to just as we close, I wanted to ask just like in 30 seconds. You got a lot of students on the line. They're beginning their careers. They all have an interest in AI and ML, or they wouldn't be on the line. And so, Anurag, in 30 seconds, like best advice to all these young students out there. Like, what would you tell them?
Best advice? Hey, listen, I'm hiring. We are doing, if any of what I told you guys about today is interesting, if the work that you want to do in your life has some personal meaning to you, in a Viktor Frankl kind of way, Man's Search for Meaning is one of the most prolific books ever written, then, ours is one of the companies you should think about, because a lot of what we do has an impact at scale on carbon emissions, and it has an impact. And we do some very cutting edge work with artificial intelligence and machine learning in particular. And it's an exciting area, much like education, is a sector where this kind of technology really just hasn't penetrated much. So we are looking for, I know there's Facebook and Amazon and all the great other places, but ours is where the rubber really hits the road. You know what I'm saying? And so you can earn your stripes working for us. So we invite you.
Great advice. So great advice. If you want to do great things, work for great leaders in a great company. That's a good one. I like it. Samta, same question, just real quick. Best advice.
I honestly think, since Anurag has already thrown the recruiting hat in there, my best advice would be just keep learning. This is such an evolving field. Just, know what you're passionate about. Just keep going. Be curious, keep learning.
Okay, thank you very much. I think I'm over. I don't, if Matt, or am I turning it back over to you, or are we?
I'll close it out here, and thank you, John, for hosting and moderating. Samta, Anurag, great content. Thanks for joining us today on Earth Day. What a noble topic. To answer your last question there, John, and for the students, engage with us in the Krenicki Center as well. We are the gateway to connecting with the business leaders such as Anurag, and starting to solve those real world problems while you're still a student. And that's what Krenicki Center is all about, is building that bridge from academia into the industry partnerships and starting to solve real world problems. So thanks again for everybody for joining. I will close this out, and thanks on behalf of Purdue University, the Krenicki Center, and Accenture. Thank you.
Thanks, everybody.
Thank you all.
Thank you both.